Hello and welcome to this video. In this video, I'm going to start showing you how to use the Numpy library to perform numerical computations. And I'm going to continue from where we left off yesterday, where I showed you how to start your own local installation of Jupyter notebooks or use Google Colabs if you don't want to set things up on your computer. So I'm going to create a new notebook and I'm going to call it Numpy Basics. So Numpy Basics. And I'm going to combine both markdown notes and then code cells to explain what I'm teaching you, and also use the code cells to demonstrate how to create Numpy arrays and then perform certain operations with them. So I'm going to start off by changing this to a markdown cell, the first cell to a markdown cell, because we are going to write some note. So I'm going to use this header 3, and I'm going to say introduction to NumPy. Introduction to NumPy. So basically, NumPy stands for numerical Python, and it is a library for numerical computations. Okay, and so the first note that I'm going to write here is that NumPy stands for numerical Python. Okay, and then the second thing that I want to tell you about NumPy is the fact that it is so important that it is now the building block for most of the libraries we use in Python for doing data science or machine learning operations. Okay, so it is also the building block for libraries such as SciPy, scikit-learn, pandas, and to some extent even Keras or TensorFlow. Okay, the number 3 thing I want you to note is that it is mainly written in C. So even though you are going to write your code in Python, what is actually happening is that the core of NumPy is implemented in C for efficiency, and then there is a Python wrapper around it that helps you to get a very nice looking Python APIs that you can use to create your NumPy arrays and stuff. But what is actually happening is, at the end of the day, it is very efficient because the core of it is implemented in C. And the reason why it is efficient is not just because it is written in C, but also because the arrays are represented using contiguous blocks of memory. And because the blocks of memory that is used is contiguous, it can easily be cached by your CPU. So the note I want you to write here is that it uses block of memory, or I can say it uses contiguous block of memory, that makes it easy for CPU to cache. Okay, and by the way, let me know how you feel about teaching and then also writing the notes for you with markdown in the comment. If it is something you don't like, I can always stop it because I feel it is slowing me down a bit. Okay, so the fifth thing that I want to tell you about NumPy is that because it uses a contiguous block of memory by design, just so it can be cached by the CPU, it is quite different from the normal Python list that you know. So a Python list doesn't use a contiguous block of memory. Rather, every entry in a Python list is stored in a random location in memory, and a pointer to it is pointed to in the list. So it is not necessarily stored in a block of memory that is contiguous for easy access and caching, but the vanilla list data type that comes with Python uses random locations and then it stores pointers to them. So it is not as efficient as NumPy arrays are, okay? And by design, they also have phased sizes, okay? So phased sizes, and they are homogeneous. By being homogeneous, what I mean is if you create a normal Python list, you are free to store values of different data types into the same list. But in Numpy, it is not the same because by design, they use contiguous block of memory and they store values of the same type. So values or objects of the same type. Okay, so these are the 5 notes that I want you to remember as far as Numpy is concerned. And now in the second code block, I'm going to show you how to create Numpy arrays. But before I do that, let me show you what I mean by it being homogeneous. So for example, if I create a normal Python list, say I want to store names. So I create a normal Python list and I store the names Kenny, Edward, Samuel, Emmanuel. Okay, this is a normal Python list. One way of knowing that is to use the type command in Python, and then you see that it is a list. Now, even though I intentionally stored values of the type string into this list, I am free to add any other values of different types to it. So I can say names.append, and then I can add, let's say, 10 to it. And if I print names, you can see that now names, which used to be a list of only string values, is now a list of strings and integers, and I can even go ahead and add different data types to it. Okay, this is not so in Numpy arrays, and it is by design for efficiency. So I'm going to hit Shift Enter just so I leave a space there, and then I'm going to show you how to create a Numpy array. You create a Numpy array by first of all importing Numpy, and I showed you how to install it in the previous video. So if you mix that, try and then watch it. So I say import Numpy as np, and this is also a convention in the Python community where we usually import Numpy and we alias it as np, so that all subsequent calls to functions and values attributes that are defined in the Numpy package will be preceded by np. So let me go ahead and then create an array. I'm going to call it arr is equal to np.array. And so what a Numpy array is basically, I want you to think of a multi-dimensional array, or think of an array of arrays, or in much more simpler terms, think of a list of lists. To make things simple, I'm going to first of all start by showing you how to create only one-dimensional arrays. Okay, so let's say I want to create a vector that has the numbers 1 2 3 4 5. So 1 2 3 4 5. Okay, this is basically how you create a Numpy array. You just say np.array, and then you pass it a list of the values that you want to go into the array. Now that you have an array, you can check the type of it using the regular type statement in Python, and you can see that up here names has a type of list, and then down here arr has a type of numpy.nd array. Okay, the nd basically stands for n-dimensional array because it gives you the building blocks you need to create multi-dimensional arrays, and it is so versatile, it is so powerful, and it is so flexible. Okay, now aside checking the type, once you create an ND array, there are some attributes that you can also play with, or you can also observe to see other things that makes ND arrays different from vanilla Python list. Okay, and one of the things that you can do is to say print, and by the way, you don't always have to use a print statement to print things out. In Jupyter notebooks, I can do print arr.shape to see the shape, or I can just do arr.shape, because the Jupyter UI renders whatever the function or attribute you call returns. Okay, so even though I like to always put things in print statements, you don't always necessarily have to do so. Okay, yeah. So what is the shape of an array? The shape basically tells you, depending on the type of array. So for example, ARR here is a one-dimensional array, which means to access any of the values in the array, you just need one index. And accessing as a single, a vector like ARR basically requires just a single index, just as you would do with regular Python list. So if you do print ARR.shape, it is going to show you 5 comma. So the reason why it is 5 comma, I will explain in subsequent videos. But basically, if it is a one-dimensional array like we have here, then it's going to show you the number of items in the array. Okay, now there is another attribute we can check, which is arr.dtype. So the dtype basically tells you the data type of the values that are stored in the array. So basically, we created an array of numbers and they were integers. So by default, Numpy used int64 to represent the integers that we placed in there. Let me go ahead and then show you one more thing, and then we can finish this video and start another one. So I'm going to create a matrix, and a matrix is just an array of arrays, okay, or a list of vectors. Think about it that way. So to create a list of vectors, to help yourself visualize it very well, I open the first list, okay, and then now I will put in each row entry in the matrix. So let's say I have a matrix 1, 2, 3, 4. This is one row, and then the second row I have 5, 6, 7, 8. Okay, so if I print out the matrix, which you can do with print, or you can also choose not to bring print. So if I print out the matrix, you can see that it is basically a list of lists, and each inner list represents a row in the matrix. Okay, and then if you look at it from top to down, then we are talking about a column. So over here we have 2 rows, which is row 1 and then this row 2, but we have 4 columns, which is 1, 2, 3, and then 4. So the first column is 1, 5, the second is 2, 6, the third is 3, 7, and then the fourth is 4, 8. So now let's see what we get if we print out our matrices shape. So matrix.shape. Now you see that the matrix.shape returned 2, 4. So like I explained earlier, the shape returns a tuple, and the tuple represents how many items you have along each dimension. So this matrix here is a 2-dimensional matrix, which means to access an element we need to specify 2 indices. The first one for the row, and then the second one is for the column. But because this video is not about accessing items, I'm not going to go into details in this video. But the take home here is that a Numpy array is basically a data structure that helps you to efficiently represent your vectors and matrices and perform vectorized computations on them. So leave your comments in this video, and I will try to address any concerns that you have, or if you didn't understand anything. So thank you very much for watching, and I'll see you in the next video.